Hello, welcome back to Organic Chemistry. We're on our second part of enolates, looking at the thermodynamic versus the kinetic enolate. Now let's start using them. We talked a little bit about how to make them. Let's put them into some practice here. So let's start with our carbonyl. Something like this. Now, the big thing is like where do we want to put that alkyl group at, right? We have the opportunity now that we know how to make thermodynamic versus kinetic enolates. We can put it at either alpha carbon, right? In this molecule here, we have two alpha carbons, here and here. And we can see the more substituted alpha carbon versus least substituted alpha carbon. Now that we have some chemistry that we can do, we can put one at either position. So let's first start with our kinetic version. We use our kinetic one. Remember what we use for our base here? We're going to use what? We're going to use LDA at what temperature? Minus 78 degrees Celsius. And that's going to make sure that we form this kinetic enolate. Also, it's going to make sure that that enolate doesn't move, right? It's going to be frozen there. So under these conditions here with our LDA, we're going to end up making what? Our enolate here. And again, we're going to turn back to mechanism. We've seen this before. We're going to pull off the proton there. We generate the negative charge on that carbon. And then our second step is we can have addition of our alkyl halide. Let's go ahead and with our alkyl halide, we'll put it down here. Let's add in, what do you want to add in? Again, it's very important we keep track of carbons here, right? Keep track of your carbons. Let's do this one. This is a nice one. Easy way to track it. And this one's going to then attack here, and we're going to kick off this group. Now remember, this is a pretty strong nucleophile. We want to use something that's going to be very useful for this. It's going to be very efficient. So we're going to stick with those primary alkyl halides. It's going to go by an SN2 type mechanism. So the SN2 mechanism, what favors those least hindered alkyl halides, like our primary alkyl halides. That's what we want to favor. And so by doing this here, again, we want to be careful to count our carbons. One carbon here, and then we're going to add one, and then this will be the second one. So one, and then we're going to add a group here. This is through our kinetic enolate. Okay, this is our kinetic enolate. Where what we did here is what? We went ahead and we made the least substituted enolate, which then attacked the alkyl halide to give us this product on this side here. This would be a great opportunity if we want to put it on this side. We can control that now. We know the conditions for that. So we can put this group on this side. But you're like, well, I don't really want the group on this side. I want it on this right side here. I want to put it on this one. Can we do that? We can now. We know a way of doing that, right? We'll go through making our thermodynamic enolate. So let's look at that. And again, we can use a different alkyl halide if we want. Let's use a carbon chain this time, just for fun. So let's go ahead, I'll erase this. I'll just erase everything. And now, if we want to make the thermodynamic one, remember what base we use for that? We're going to use our, not as strong of a base, relatively, right? We use sodium hydride. And again, we're going to do this at 25 degrees Celsius, right? Basically at room temperature, just about room temperature. And remember, this one here, it's going to go a little bit slower to room temperature. We're going to go ahead and we're going to pull this off because we need a little more heat there. And we'll generate this enolate here. Now, we could go through and do the resin structure and do all that, but really we're more interested in just doing the reaction with this, having it react with an alkyl halide. So this was our first step. Our second step is an addition of our alkyl halide. You want to try a different alkyl halide this time? Let's try a different one. How about something like that? And the same thing. Again, it's a primary alkyl halide. That's the important step. Let's attack there. And then, as we saw before, one, two, and three. 1, 2, and 3. And then now we can form this group here on the more substituted side. So we have the opportunity to put an alkyl group either on the more substitute side or least substitute side based on our chemistry, right? Based on using our different reaction conditions to do that, right? And then we can put all kinds of groups here. It gives us a lot of opportunities to start building those carbon-carbon bonds. It's really important. That's what we like to see in organic chemistry, is building carbon-carbon bonds. It's a great opportunity to do that. Now that we have this, now we have a carbonyl, we can do some other stuff with this carbonyl, right? We can change it into different things. So it's a great opportunity to build some carbon sources, and then we can then do some reactions with that carbonyl, change that functional group here. So let's look at one more example before we finish up on our kinetic versus thermodynamic enolates. So let's do something a little more interesting. Let's do something like that. And let's go through some steps. So first step will be LDA, minus 78 degrees Celsius. Oops, a little big. We'll use a, how about ethyl iodine? And then we'll do step 3, will be LDA again. And then step 4, let's put in another group here. We'll do CH. Let's do it this way. About that. Okay. So notice here we're actually doing 2 steps. We're going to make an enolate, then attack it with alkyl halide, and then we're going to make the enolate again and attack it with our methyl group. Now the question is, where are these groups going to go? Are these alkyl groups going to go on the same side, or are they going on different sides? I don't know. Let's find out. So let's go through our steps for this. Let's go through the mechanism. Well, we won't go too much into the mechanism because we've kind of seen this stuff before, right? So I know my first step's LDA at minus 78 degrees Celsius. And again, we're going to pull off the proton. I don't necessarily need to show off pulling off the proton because we've done that quite a bit already, right? And look at this one. This is actually symmetrical. So let's go ahead and we'll just draw what the enolate will look like. We got to practice just drawing our enolates. And I draw an enolate right there. Okay? So we used our strong bulky base and we pulled off that proton. Again, did it matter which side? In this case, no, because it's symmetrical, right? They're the same alpha carbon. So let's pull off that proton. We generate the enolate. This enolate is going to attack our alkyl halide. I'll draw that just for fun to kind of show that. And look at there. We're going to add in what? We're going to add 2 carbons here. Okay, 2 carbons. So we'll go here. All right, we've added 2 carbons to our carbonyl. Now we're going to do what? We're going to add in our LDA again. Minus 78 degrees Celsius. All right, now LDA, minus 78 degrees. We're going to generate that kinetic enolate. Kinetic enolate is going to be on the least substitute side. Which side is going to be least substituted? Our left or our right? It's actually going to be what? It's going to be this side here. This is the one now that's going to form our new enolate. So you saw what happened there? We started with the symmetrical one. We did LDA minus 78 degrees, generate enolate. We attacked it. And now we've added a carbon group to this side, to this alpha carbon. So if we do LDA again, it's now going to what? React on the least substituted side, which would be the opposite side. Now we generate enolate here because we have a difference now. We have 2 different alpha carbons, and we're going to attack from the least substituted alpha carbon, which is going to be the left one. We make our enolate here, and now we can attack it with our alkyl halide. And we get our final compound here. We get something like that, right? We're able to quickly construct our molecules here using our enolate chemistry, making the enolate, then adding alkyl halide in there to do our reaction. In this case here, we did it twice. But notice in our second one, we didn't add to the same carbon because now once we've added this group here, we have different alkyl halides to work, or different alpha carbons to work with. Now we're going to use LDA to at least on the least substituted side. So it's kind of an interesting synthesis going through these steps here to generate this compound here. And then once we have this compound here, now we have built some carbon sources, put some carbons on here. Now we can do some more chemistry with this one, right? Now we can start doing some chemistry with that functional group there. We can change the carbonyl to something else, right? So this is some examples of how we can use LDA on these molecules, or we can actually use our sodium hydride at room temperature, 25 degrees Celsius, to put things on the more substituted side, all right? So So some examples of using enolate chemistry to add alkyl halide groups on.